Great. Okay, so let's start the course more officially by talking about game theory and why do we care about it. The course is the introduction to game theory or computational game theory, actually. And it is a big difference because just game theory, the people in like economists also consider it a lot. Here, the computational aspects are very important. And I will talk about the applications. The computational aspects are really important because this is somehow $1 trillion business. We will talk about. Good. And this would be introduction to the introduction course. Uh, so, what is game theory? Generally, I mean, we can consider that there are some people, or I don't know, even animals or anything, creatures, or maybe robots. Yeah, these are self-interested agents, or we call it selfish agents, which is a very natural assumption. Almost every person that you will find, even a virus, is a selfish uh, creature. So, and then the whole idea is that what is the interaction between these guys, I will say, or these creatures, or whatever, or agents, actually, we will call it. And each of them have different preferences. It means that they like different outcomes. Like, for example, if you consider the game between viruses and the human, is that, like a particular human, that these viruses, again, they are working actually in a very distributed way, a beautiful way, bacteria even. They are doing in a way to, I mean, get the food on, but at the end, thing is that they are killing the person. The person try to essentially kill them, or at least put them under control. And these are actually, as I mentioned, even the bacteria. They are playing games. So that's another interesting thing. For example, this was actually, I was talking with a biologist before, and you just see what are the games that they are playing. That, for example, when what is the reason essentially uh, to do like toothbrushes? The main reason is not that you can kill all the bacteria. The only thing that you will do essentially, especially the toothpaste, is that it try to keep the density low because these bacteria are all there essentially. But they understand through, relatively complicated mechanism. They understand how many of them are there. They are not attacking your tooth unless if they know that there are enough number of them. Then they will attack. And that's it. And otherwise they will be somehow hidden. You see, even those guys, they are doing it. Of course, all these animals, but this was one example that you can see that. But and this is the one that I have mentioned previous time. After this course, your view about the world will change, good or bad, because then you will see the world from a different lens. Then you don't see, maybe a little bit, like when you see the people, you are just seeing this, like you may see as a robots, I don't know, but maybe see as the agents, essentially. That each person try to essentially maximize his or her own benefits, essentially. Even may say that some person, for example, these are even some of these studies, like if some people are kind, but this kindness actually maybe because it satisfies them. So at the end, it seems that at the end, something is selfish is there. Again, this is some more philosophical thing, you can discuss it. But I want to say that this is a very reasonable and very realistic assumption. And as I mentioned, different people have different preferences, and thus they like different outcomes. Here in this course, we are giving essentially definitions and technicality of these things, and in particular, the concept of equilibrium. The equilibrium is that, okay, they are starting it, and the games are generally essentially repeated games. These are playing with each other until we reach some equilibrium. I say, okay, I'm fine, you're fine, and that's it. A good example of that, in some sense, for example, a settlement in court. It's exactly this kind of equilibrium that the people try to get something from each other. At the end, say, okay, we are settling the case. You get this, I get this. That's it. Finish the case. And we try to generally understand this equilibrium things. What would be the equilibrium? And not only that, sometimes we consider the path to the equilibrium. That's also important. And as I mentioned, better understanding of the real world. I don't say games even, I will say better understanding of real world period. And I mentioned, you see essentially the world different. It changed my essentially view the whole time that I'm studying this type of things. Good. There is another concept also that you will hear. It is algorithmic game theory. So algorithmic game theory. So we talk about game theory, as I mentioned. That is part of like he's an economist or everything. We are talking generally about computational issues. For example, one thing that would be important is that you will reach some equilibrium. How long does it take to reach? That is important. That's some kind of computation. Another thing is that, like this is another aspect, is this concept of algorithmic game theory. That is, I think there probably when I started my PhD, it was like almost a hot topic part at that time. Still, it's a very important and interesting thing. And in particular, the conference that I have mentioned, ACM EC. Actually, it was named electronic commerce before. Then they didn't want to check the EC, they changed it to economics and computation. That lots of them is about algorithmic game theory, and it actually started with in the high era of like or when game theory was a very hot topic. Algorithmic game theory. So here in the algorithmic game theory, we are considering incentive-aware algorithms. What's the meaning of it? So, and again, if you want to, this is important for your background. I think you need to have a strong background in algorithms. And as I mentioned, those YouTube things that I have it, like for introduction to algorithm would be good. I think I really suggest that look at them and just make sure you know everything. Maybe you know some concept, but you don't have everything, because we are referring to them as we may use them. But a simple example in that course is this. You want to sort a set of objects, a set of numbers, computer, a very typical thing. What do? You will just swap them. So there are lots of things. Say you are using quick sort and swap, and you will sort. That's a typical example of an algorithm. However, when we talk about algorithmic game theory, we are not talking about this kind of dumb objects or something that they don't understand, like numbers, who cares about, or two records. You will just, these are objects in some sense. We are talking about self-interested objects, smart objects, selfish objects. And then how can we design some desired outcome with this kind of selfish agents? In a sense, you can actually consider this one a mechanism designer. A mechanism designer is the person who designed this mechanism or this algorithmic game theory, essentially. And this person is also a player in that game. So all of those guys, they have their own things. And this other guy that designing the algorithm is another player. Everything is essentially game between this. Now, what is the object of this mechanism designer? The example that I have given. So we want to sort the numbers. Now, say there are a set of people in a line to get, I don't know, food, for example. I think I have seen a lot in Europe downstairs. The people are there. And then somebody is coming, say that, sorry, can you just swap this? I have some objective. What is the objective? Is that I want that minimize, like make sure that no one misses the classes, because the longest line, and I want to just change it. Or like this is the same thing that you may actually see this one in airport security. The people are very, I mean, generally, I will say, will be unhappy if somebody wants to do that. Because, okay, I have been here. Why you want to bring 10 people before me, essentially? These are, that's the, so in some sense, you are sorting, for example, according to how many minutes we have until your class. We want to sort it according to this criteria. And this is just a number. However, you are dealing with selfish agents. And this guy, I mean, they have their own objective, their own outcome. You cannot just say, please swap. No, it's not fair, essentially. And this, particular, this concept of essentially fairness comes a lot. And this is the idea that we are doing algorithm design plus game theory together, combined. So you need to consider the incentives of these people. In some sense, mechanism designer in this case, sometimes you will consider essentially like a god or something like that, design the things. But at the same time, this I don't know, god or anything you will call it, also plays with these guys. Has some objective. So yeah, so that's the thing. Sometimes then we have this concept of money that it is involved. For example, this in this case, maybe this guy has some money. So I have got some money essentially from the CS department to maximize the quality of life for students. I mean, rare event. But in that case, I mean, that person may say, okay, I will give you some money if I bring you someone in front of you. Then you can design some mechanism there. And the people may accept that. So if you give me free food, maybe I can just wait. I mean, who cares about this class? Maybe because my class is online. You can just watch on your cell phone while you are waiting for the food, essentially. And you can get some money, say free food. So when there is money, then also becomes more interesting. We will, I mean, touch several things, especially about the action design and something at the end of the class. But I need to say lots of things before that because it's a very actually. As I mentioned, you can somehow consider the things in the economics is somehow game theory essentially. So you need to know, I mean, more knowledge, have more knowledge such that we can discuss there. And there's a graduate course that I mean, once in a while I teach that. I mean, I'm not so sure next semester, but I may teach it essentially the next couple of years if you are around you can take it, and then that will be more advanced things. Again, if you want to know more about it, one of the best conferences is economics and computation, ACMEC. There are other conferences and other things, but this is actually more focused on this thing. You can see what are the trends essentially in the concept of especially algorithmic game theory. uh, uh, Good. So hmm. So some fields where the game theory is used, essentially anything like any businesses, anything that economics makes sense essentially. Like for example, market and auctions that we will talk about it, especially about auctions. This part is $1 trillion business. Economic predictions, bargaining or fair divisions. These are, I mean, you can think about essentially that when you bargain, sometimes essentially you get something, or two countries may actually do something. We will give some more uh, ideas there, but I want to give a particular example here. What is that particular example? That is $1 trillion business. Anyone can have a guess? Government. That's actually good. So there is one actually it is important, the healthcare. Healthcare actually is a very big thing essentially, like the government uh, issue essentially about healthcare, Medicare. These are some of these, there are a lot of money involved. And we had actually a colleague here, and he said that I hope that lots of these smart guys that are going to Google and others, they are coming actually solving the problems here because there are much more complicated problems here. The money is also huge. But the other one, I mean, the one that is also maybe more famous, I mean, and especially I will say algorithmic game theory in computer science was really inspired by that, or advertisement actions. Yeah.
Or the stock market?
Stock market as well, yes. I'm surely stock market is another thing. I will actually give a story on that one.
That can be a lot of theory to predict when people are buying and selling. So you know when yourself to buy and sell.
Yes, but as I mentioned, everything in the world is game theory, so it is not a very thing. But these are like some famous ones, essentially, stock market, as I mentioned, about the healthcare, lots of things there, essentially. And but one thing that I want to particularly talk about it, especially in the community of like computer scientists who are working game theory, advertisement action was very important. Why? Because these businesses, they didn't exist. I mean, before maybe 1998, maybe before Google, Facebook, Microsoft existed, but I think that also got lots of benefit. More importantly, one of the important player, Amazon. Amazon now essentially became, after Google and Facebook, the third things. I think at some point Microsoft was the third thing, but now Amazon is that. And they are making a lot of money. And I worked there, so I know the thing. So and there are tons of advertisements actions that we, again, this is some of the things that we can discuss like maybe in the future, like or in the other courses. But I want to just give you the idea why this is important. Like I mean, there are some of my students actually, they are getting very good jobs in top notch things, like essentially this FANG stuff. I think they are saying that Facebook, Apple, Microsoft, I think FAMG, they are adding it. Anyhow, the other, Amazon. So, and the main reason is essentially and the people thinking about machine learning. So, machine learning is very important field. However, this algorithmic game theory, I will say, actually, that's the real gold, essentially. That's the real treasure. Because all this, and actually, not too many people also, they have this knowledge of you need to have a computer science knowledge and game theory knowledge, and then you can combine. And that is rare. Not too many people actually are trained to do that. So that's the thing that I think is a beautiful thing for you to take this course, because now you have the concepts, and it would be good if you go beyond this course and learn other materials, such that you can use it essentially for your next job, either it is in academia or even actually maybe better in industry. So this advertisement, every display ad that you are seeing essentially on the like any pages, these are all game theory data. All actions are. Another example, sponsor products at Amazon in particular. If you go at Amazon, then interestingly, you will see on top of the page, say some of this is say sponsored ads. And these sponsored ads all are coming from advertisement actions. And we talk essentially, and not only that, this is not just a game theory part of it, which is important. And there are lots of things essentially. I mean, we will talk about generalized second price or other type of thing later in this one. We will talk about auction. But so there are some economic aspects, but more importantly, computational aspects. Why is the computational is so important? Because you will go to a website like Amazon, for example, for a sponsor. This is essentially something like a sponsor products versus others like Google that you will see advertisement, or Facebook. I mean, you have seen enough advertisement that you have seen. Those that are called display ads, essentially. There are some others essentially that are saying that, for example, there are search ads, there are sponsored ads, sponsored product that is more like at Amazon, or for example at Overstock. These are some of the things that I am guilty of building some of them essentially. That these are actually nice and help people. And it is interesting. So all these things, generally the time that you view some page, you have 20 milliseconds. Sometimes maybe they extend the thing, the display ad 120 milliseconds. Sometimes you will see the display ads come a little bit later when you go to it. But between 20 milliseconds to 120 milliseconds, you need to do a very complicated, essentially stuff, such that you will essentially select who is which advertisers ad you want to show. And this is among, like, one advertiser may have several ads to show, and there are tons of things. Just give you an order. I mean, how many ads are there? If I remember correctly, that back in maybe 2020, I think in each hour, it was something like the number of auctions that was generating, or the ad slots that they are running, that was around more than, I think, 60 billion in each hour. And I have particularly worked on some of this, as essentially Amazon, and that was exactly this concept of computation versus money that you will get it. The computation becomes so important that I emphasize that, because this course is about computational game theory. This is a very nice place that you will see some kind of trade-off. You may not actually, so this in the display ad, I mean, for display ad, you are running auctions and advertisers pay you something. However, the process of selecting the best advertisement and actually bidding for that, it is so expensive computationally that you may decide that you don't want to bid on this ad, or you want to pass on this ad, or you may not even want the display ad. Like, if you want to, for example, as a DSP, as like somehow that you want to, I mean, get the advertisers ads and then select one of them and then compete in some of these auctions. You may decide that you don't want to do that, because computational issues actually would be so much that the cost of computations, that would be more than the money that you will get from that. And this is exactly the trade-off. That was also another interesting thing. Like, this actually, some of this computation, like Amazon was doing it. So, for example, giving the separate thing for the ads. At some point, they decided, no, it is a wrong thing. If you want to write some programs to filter ads, etc., and others, you decide there, you should use the AWS, because AWS is the place that you pay for computations. Now, if even this is the internal things, if you want to do that, you need to use AWS, and you need to pay the cost for that somehow internally. Why? Because you want to make sure that you don't take the computation for granted. You think that you are doing some good things, but at the end, actually, you are hurting the company, because the cost of that computation, I can sell that one to the third party and get money from there. Then I'm using it for advertisement, and I'm losing money, essentially. Some of them, for example, display ads are known, and display as a typical thing. Like, when you go even to some kind of app and then you use some advertisements, they're all display advertisements. We will talk more about it later in this course. All of them these are like very hard things. The margin is not that much. Other ones, like, for example, a sponsored product, the one that you are going there, as I mentioned, especially at Amazon, for example, you will see it, or like some of them in the search ad at Google, these are much more profitable. But anyhow, all of them, the computations play a super important thing. Exactly because of this 120 milliseconds at most that you need to answer the ads, you decide who should be the things. And on top of that, you may want to make sure that, yes, you may answer it by using lots of computation, but you don't want to do that, because the compute cost will be more than the money that you will get from the advert, or the profit that you will get from advertising. So that's a particular, set of auction. And this is $1 trillion. These companies that you will consider, Google, Facebook, I don't know, nowadays, there are a lot of Snap, you name it. Like Amazon, as I mentioned, especially the third one, Microsoft, Bing, all of them are essentially doing advertising. It is not even like you go to Home Depot is now running that. Some of them actually run by some other companies, like I think Home Depot by Microsoft, or Lowe's, I believe, by Google, essentially. They are running that. This is other Wayfair, for example, another one, Overstock. Now he's also known Bed and Bath. They bought that. These are all companies that they are using this type of thing. And this is a super important thing. And the value of this company, if you see that all of them got advertisement, and these people, they really want the people in this field of game theory, algorithmic game theory, that both computation stuff and the economics stuff, such that you can do that. And that's actually in the best class, one of the best classes that as I mentioned, undergrads, there are not too many other places that they have even some kind of courses. And if you want to do more about it, just go these potentials of e-commerce. I'm talking exactly about this kind of display ads. I mean, the way you can, that's a very important one actually to know, because like I try to again put all my experience on that 1 hour things. I'm talking with a colleague essentially on those things. And you can get a very good ideas of how is it going. And otherwise it would be much, much harder. In 1 hour, you have a much better word about it. It took me actually a long time to get all these details, but I was at the end of some center of that and I could do that. So please go and do that. And one thing that I to also, please go and do it, like watch those videos, I think. Those potentials of e-commerce, especially very related to this, among the other things that are there. Good. So we gave essentially some examples about, market, and in particular, advertisement action. That is, as I mentioned, is very central for computer scientists. And again, these companies, all tech companies like Google, Facebook, all of them are tech companies, and these are based on CS. So that's the thing that actually is very interesting. Of course, the other one is economic prediction, and the other one is the stock market. That's another actually a story that actually I think that was for maybe that back in 2019. I believe that at that time actually there was always a stock market. I didn't invest in the stock market that much, other than retirement, etc. But at some point, I felt that I should, if I work on the game theory, I should know about the stock market. And I mean, for a while, actually, I was a day trader. And I think that was a very great experience. I have written lots of software for that. Actually, some of them I'm still running it, but some of them maybe I need to update some of the software. I have actually created this website Predicta, predictaa.com. You can check it. I think I'm not so sure whether it is running now because I need to. Sometimes I get busy and this running is a bit of hassle because I think 10, 20 programs are there and I was running all of them. And if one of them is not working, it's not working. But I have written this software that actually can do the predictions. And based on that, I was using that and you can actually use them for like stock trading. I think that was a great experience because I learned a lot from stock. And then we have another interesting paper, actually, if you are interested about it. We are using the game theory concepts, and this was based on that things. It is called trading profit. If you search this paper, that's a nice paper that we have. We talk about the stock market, and actually we get some theoretical results. It is on arXiv, the paper, and I actually appeared in this economics and computation conference as well. That's a very nice one that tells you what you should do essentially for stock market. Not what you should do, but give some basics, and that basics are actually important. But anyhow, you will go there, and this is another very important one. You need to prediction, and you are playing with lots of these giants essentially. And of course, more importantly, with the Fed as well. Before Fed, maybe, of course, it's always very important, but now deciding that this guy essentially, Jeremy Powell, is coming and they say just one word, and that word the people try to, the whole market may crash or may go up essentially. And again, you're playing with some of them that you know, some of them you don't know. And this is another one. As I mentioned, this kind of fair divisions is other things that you can think about it, or bargaining. And there are lots of research on that. Let's go for the... some other fields that are done. As I mentioned, government policies, or in some sense, essentially all the policies that government is doing, that politics and military, all of them are game theory. And in particular, like the whole Senate, for example. I'm currently actually a UMD senator, but that does not happen that much like in the real Senate happens. But there, the people are negotiating all things about negotiating, all things about game theory. And as I mentioned, the thing that we care a lot about it is about settlement. That settlement means equilibrium. And that's exactly the thing that we try to understand, the other thing. And of course, the path to that is important. For example, you may think about the national ceiling debt. You see, there's lots of things in the news, and then at the end, they generally settle. Sometimes they may need to essentially make the government close for a week or two, but eventually they settle. But the path is important, because if it's a smooth path, is quite different from if it is like too much negotiation and like going to the closing the government, because then, for example, the US credit score in some sense by some of these companies may go down. That happened actually recently. And that changes the whole stock market. So the path to that is important. If it's a smooth path, or they are negotiating and the people are afraid that maybe US does not pay its own debt essentially, or the interest on debt. That is also important. So the path is important. How long does it take is important. And all this, that's the thing that we are talking about. As I mentioned, so all vote essentially things. That is another another game actually. If you want to see among my papers, if you search about the kernel blotter game, that if you search, that's also we have, it is called blotter game, BLOTTO games. That's actually, they're beautiful games that talking about different things and like presidential elections, wars, etc. That you can actually look at, and there we had some nice results there actually. Some important problem after almost 100 years, some computational aspect of it. So you can talk about it, international relations, war. I mean, of course, everything. You just consider like the current war between Russia and the West, I will say, Ukraine and the rest. Everything is about game theory. And yeah, and so that is the, I mean, you can get a lot. Another thing, as I mentioned about the biology, psychology, and sociology. So, for example, the example that I have mentioned about bacteria in a mouse, or like you can consider any other type of, I mean, animals or biologists. Everything essentially is about like game theory. Another thing is about like sociology, and like, for example, something like Facebook. That is another type of thing that is not in terms of advertisement, now in terms of the people are connecting, like Twitter, etc. Everything essentially is game, and then who is connecting to whom and how many followers you can get it. The followers turn into money essentially at some point. These are all important things that game theory plays an important thing. And again, hopefully after this course, you have this view that you will see it, the whole thing as a game. If you say each of them as an individual thing, you may not get it, the exact relation. But if you see all of them together, you have a different lens again. You have a maybe different view. But as I mentioned, that is good or bad. Maybe it is not because if sometimes it's better that you don't, like, I don't know, just think about this way that I think that you are in an airplane and something bad is going on. The question is whether you want to know it at that time or not. Because the chance that that bad things maybe, I mean, at the end does not affect you. But the issue that if you know everything, then you have lots of stress. And that's exactly the thing that I mentioned, good or bad. So if you see the whole thing as the real world, then you have lots of stress essentially, because now you will see, oh, this guy is cheating actually. Otherwise, if you don't know, oh, this is an honest guy is doing that. But really, this guy is cheating. He is doing lots of other things because of the selfish things that he has it or she has it. And that, knowing that, is quite different. That you think, oh, this is the honest guy. He has done or she has done these things, and at the end of the day, maybe everything is okay. But in the middle, if you understand this was some kind of games are going on, that you may or may not be happy about it. So that's the thing that I mentioned. It is good or bad. I mean, you can maybe close that eye after this course, but it would be hard, I will say. So this is like this Hotel California thing that once you come, then it would be hard to go out. But anyhow, so the other things, of course, I mean, these are about the game thing. I mean, like all these game programs or like the computer science in general, but lots of these games, of course, these are all coming from games. And on top of the games, the people are playing games. Like, for example, now you will have some games. On those games, you are earning some points, you are or money, and then you will pay to buy something in the games. And all of them is somehow a game on top of the game. Another interesting, computers and communication networks. All of these things that you are sending over internet, essentially TCP/IP. These are like some of the things that how these people are playing. And another interesting thing, you may have seen nowadays, actually, Google is playing a lot of advertisement for Google Fi, essentially, that you will get the Wi-Fi. I mean, one of the main reason is that there was this kind of net neutrality act that actually it was gone. It was there before, essentially, in the telecommunications things. Now the people can charge, like what the whole idea that when you are at your home and you are, for example, using Verizon to see Netflix. Now there is, before there was nothing. I mean, Netflix was doing its own things, and Verizon, you are getting paid their things. But now Netflix needs to pay something to Verizon, for example, because you are using on my backbone to see a lot of traffic from Netflix. You get the benefit. That was essentially one other issue that this telecommunication company, and it is a case like Verizon, AT&T, T-Mobile. They didn't. I mean, they were actually very super hot before, like maybe before 2000. But then they lost the thing to other tech companies because these tech companies, lots of the traffic are just doing through their networks. But the actual money is the one that these companies are doing that. And that is interesting. Actually, when I was at AT&T, I mean, back in like 2007, I think, to 2013, we were discussing all these things that at that time the Google map was not still the main, not very topic or very limited like this. And this was our idea that like actually this is I think I made a patent even about that you have your cell phone. From this cell phone you can find essentially your place by some kind of triangulations, because AT&T could do that at that time. I mean, you have some power from tower, you see what is the thing, and then based on that, we are sending essentially some text advertisement for you. That's the thing. Actually, we have done it at AT&T. But I mean, of course, the Google, because of all these cell phones now, they have, and at that time, not too many people had their smartphones even. Like iPhone was just recent, essentially even. But now everyone has smartphones. Then, of course, then Google, especially, is very beneficial for them because they know everything. Like Google and Apple, they know about everything about you, as I mentioned. It is called datafication, essentially. And they have their thing. So this one and the road networks, of course, road networks, the whole thing. I don't want to give anything better example for that. That you are in some lane to go to some essentially ramp, and then somebody comes, and at the end of the ramp, it comes in front of you. This is the whole game that you are seeing, or the whole traffic is. So and again, this is just this thing that we discussed are just some examples. In some sense, the whole world is a game. As long as there's some intelligent thing is going on. I don't know whether in Mars or other places that there is no selfish agent yet, at least as far as we know. I don't know whether at the level of atoms or so, or there are some games are going there or not. That I cannot claim. But for all practical matters, the whole thing is a game. Recording. Good. So we talk about the applications of game theory for lots of, places in the world. And I mentioned essentially the whole world of creatures or something that has a little bit of smartness means probably that thing is selfish. And that means game theory is good. So that's essentially the story of the whole world. Now, here I wanted to play some game, essentially. This is actually interesting. We will run it here in the class. What is the game, essentially? So I need to, two volunteers. I think the people on Zoom, it will be harder. So the people from the class, yeah, already we have two. These two people are coming. They don't know each other. Do you know each other? Okay. And, we will talk even when you know each other or you don't know. And you have a chance to get some chocolates. I mean, actually, my previous classes, I had the chocolates and I was bringing there. But at some point, I stopped because I felt that, this is not a healthy thing. And I could bring carrots, essentially. But, yeah, I don't know. It is a little bit of things. Actually, we might have carrots today, actually, running this. But anyhow, we will do the game one way or the other. Good. So, what is the game? So this is the game that you want to play. So such that you have some ideas about. And this is again seems a simple game, but it's very famous game that we talk related to prisoner's dilemma. And this is the game. So these two volunteers, you will come to the front of the room. you will face opposite direction. Don't talk with each other. This is one way. We will run it some other things. And you may choose one of the two actions. And you don't know, I mean, you don't say to anyone, you just write it down. This is a simultaneous game. And then we will talk about it. And what are the actions? So this is the chocolate dilemma. There are two, this is the actions that you need to take. And this was, I mean, if you want to know more about it, you can go to this link. And again, all slides are available from website, the course website. So this is the take one and take three. Take one is that you will take one piece of chocolate and you may keep it for yourself. The other one is that you will take 3 pieces of chocolate and they'll go to the other player. Good. And then we want to see, I mean, what will happen in this. And then, I mean, we will discuss, I mean, after this game, we will come back and then we will discuss some other aspects of it, essentially. And, I mean, you can play lots of ways, but this is the one that we will, so these are the other aspects of the thing that we will talk about it. But say, okay, let's, I mean, start the game and then we will talk about it. Okay, so we are done with this game. We have played this game essentially in 2-3 ways, like the regular one, the one that instead of no negotiation, you are negotiating and then you play. And the other one, instead of take one, you get 2 essentially chocolates. And you see, each small details actually can have a huge difference. You may see huge differences in the outcome of this game. So we will talk more about these games, and the more essentially we have played games, so we try to motivate it as much as possible. We talk about some math behind it next time, and then we will talk about even more math. So good.